In this video, we'll be learning how to make a box and whisker plot for a set of data. So a box and whisker plot is a great way to show the variability in a data set. And essentially what a box and whisker plot displays is it displays a key 5-number summary. So there are 5 key numbers that help us when we create a box and whisker plot, and we put them on our box and whisker plot so we can start to evaluate them. So here you can see that we have our least value or our minimum value and our greatest value or our highest value on our box and whisker plot. So essentially, if we have numbers on this number line down here, we have a really good idea of where the lowest and highest number are, and we can calculate our range by subtracting the two. So we can see exactly how far apart all of the numbers are. Then from here, we also find what's called our median, so that middle number, and that represents what's called Q2, which we'll talk about on the next slide. But this median number tells us what the middle number is. We'll be able to visually see that as well, and we'll be able to visually compare, okay, is the middle number closest to the maximum number or closest to the minimum number? Then from here, we also find third quartile and first quartile. And our third quartile is the middle of these top half numbers, while the first quartile is the middle of the bottom half numbers. So again, you can look at how the spread varies even just by top half compared to bottom half. The other piece that I really like here is you can see exactly how far apart the bottom half of the data is. And then you can see exactly how far apart the top half of the data is, and you can see, which direction the data is skewed. So by having these 5 numbers and being able to visually display them in a box and whisker plot, you can get a really good sense of the variability within that data set and what that data really looks like. Now, as I mentioned on the previous slide, we have some new vocabulary words here that we haven't seen before. The first quartile is the median of the lower half of the data. So here, when we find the first quartile, we're focusing on this lower half data here, and we're finding the median or the middle number within that data. The third quartile is similar. It's the median of the upper half of the data. So we focus just up here and we find the middle number up there. And then the second quartile is something we're already aware of. It's just representing the median, but it's called the second quartile because it's in between the first and the third quartile. It's the middle number in there. And essentially what this number does is it divides that data set into 2 different halves. Now, in addition to finding a normal range, which we know is our maximum subtracting our minimum value, we're also going to find what's called the interquartile range, or the IQR. And the IQR is the difference between the third and first quartile. So to find our IQR, we'll take Q3 and we will subtract Q1 from it. And this will represent the range of the middle half of the data. So while we do care about the very, very maximum numbers and the very, very minimum numbers, the interquartile range really focuses in here on this middle data. And so this middle data right here, how far apart are the middle of the top and the middle of the bottom? So this middle data, where do the middle numbers occur and how far apart are those numbers? That is our interquartile range. So let's go ahead and jump in and make our first box and whisker plot. Now, to make a box and whisker plot, we are going to have to rewrite these numbers in order from lowest to highest because we're going to have to be able to see that variability a little bit better to draw this image. So here I'm going to look and I notice that my lowest number is 18. Then my next lowest number appears to be 22, and I have 2 of those. My next lowest number is 24, followed by 2 25s. A third 25. Then we have 27 and 28, followed by 3 30s. So from here, what I like to do is the first thing I like to do is find my median number. Now, I'm not going to necessarily cross everything off here, but I'll count from the center, from the outsides into the center. So here we have 1 on the outside, 2 on the outside, 3 on the outside, 4 on the outside, 5 on the outside, and I notice I have 2 numbers in the very, very middle. So my Q2 value, or my median, is going to be the average of these two, which is 25 plus 25 divided by 2, which is just 25. So my Q2 value in the very, very middle is going to equal 25. Then from here, I'm going to focus on the data in halves. So I'm going to focus on this half here. And in order to find my Q1 value, I need to find the median of this data underlined in blue. So I'm going to start and go, okay, these are on the outside. That's the outer numbers of the bottom half. Then there's those two. And there's these two in the middle. So to find my Q1, remember I take the median of my lower half of my data. So I'm going to average these two numbers. So we end up with 46 divided by 2, which is 23. So we have a Q1 that is equal to 23. And then I'm going to repeat this same process up here with the top half of the data. So I'm going to focus on this data right here. And again, I have to find the median. And so I notice I have 2 numbers here, so I'm going to average those. So 28 plus 30 divided by 2, which gives me 58 divided by 2, which leaves me with a Q3 value equal to 29. Then from here, I know that I already have my minimum and my maximum, so I have a minimum point here equal to 18, and then I have my maximum point here equal to 30. So I'm going to be able to create my box and whisker plot by having those 5 values. So the first thing I need to do is I need to create a number line that ranges from 18 all the way up to 30. So I'm going to draw my number line here. Here's 18, then we have 19, 20, and then there's 22, 24, 26, 28, and 30. And we know that our median, or our middle number, is at 25. So I'm going to plot that here because that's going to be the middle of my box and whisker plot, and that's going to line up right at 25. Now, the lower part of my box and whisker plot goes down to my Q1, which is at 23. So this is the lower box down here. So I'm going to connect those two, and that is the lower half of my box. I then have the upper half of my box up here at 29. So I'm going to connect those two as well. And just by using Q1, Q2, and Q3, I'm able to create that box. Then from here, I need to draw my whiskers, which help me when I branch out and look at the outer data. I'm going to look at my whisker goes all the way out to 30 here for my maximum point, and then it goes all the way down to 18 here for my minimum point. So here we can see our variability is a lot more visible. We can see our middle is there, that median is there at 25, and then we can see how the spread kind of works out. Even just looking at this box, you can see that this, quarter of the data between Q1 and Q2 is very small. Same with this quarter of the data, but this quarter of the data takes up more space. There's a lot more numbers and variability in there. So that's our first box and whisker plot. Now typically with box and whisker plots, you also need to calculate your range and your IQR. So our range here is going to be the max minus the min, which in this case is 12. And then our IQR, which is our interquartile range, we find by taking Q3 minus Q1. So we're going to do 29 minus 23, and that equals 6. So let's create a box and whisker plot for one more set of data. So here we have a basketball player scores from a set of various games that they played during the season. So let's put these in numerical order first. So we have a 5, and then notice we jump up to 14. We then have 16 and 16, followed by 20, 20, 22, 28, and 30. So to start, I'm going to find my median. So I'm going to find that Q2 value. So I'm just going to find it by imagining I'm crossing off from the outside in. And here is my median value. So we have a Q2 value, or a median, equal to 20. Then from here, I'm going to focus on Q1 and Q3. So Q1 is going to focus on the lower half of this data. Notice that I'm not including the median here. So if we just have one single median, then we just focus on the data to the outside of it on each side. So here we're going to find the median of the bottom half of the data, which we can see is the average of 14 and 16. Well, 14 plus 16 is 30. 30 divided by 2 gives us a Q1 equal to 15. Then from here, we look at the top half of the data, so above the median. So again, remember, if we have one single median, we just focus on the numbers to the right and to the left. If there's two numbers that we average to create our median, we put one in the top and one in the bottom for our Q1 and Q3 values. But with it being right in the middle here, we don't need to do that. We can just focus on above the median and below the median. So here we need to average these two numbers to find our Q3, because those are the middle two numbers of our top half of our data. So we have 22 plus 28, then we're going to divide by 2. So 22 plus 28 is 50 divided by 2. So our Q3 value is equal to 25. Then to end, we have our max at 30. And we have our min at 5. So when I create this box and whisker plot, typically you can go by, you can go up by 1s on your line, you can go up by 5s, you can go up by 10s. What I notice is kind of unique about this data set is that we have 5, 15, 20, 25, and 30. All of those are multiples of 5. So just for the sake of time, what I'm going to do is I'm going to have my number line increase by 5s, just so I don't have to draw 30 little tick marks, but you can certainly draw 30 little tick marks if you would like. So here I'm going to have my 5, 10, 15, 20, 25, 30. So I'm going to label those that way. And then if you want to draw your little tick marks in between, so it would be, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19, so on and so forth. You can do that as well. So now from here, I need to draw my box and whisker plot. So I know that my median goes in the center here. I'm going to draw that right there. And then the first box goes up to 25. That's our Q3. Second box goes down to 15. So there's our Q1. So we can see that data variability in there. Then from here, our whiskers go up to 30 and down to 5. So we have all 5 of our numbers in our number summary displayed. Then finally, we need to end by finding our range and our IQR. Our range, remember, is max minus min, so 30 minus 5, which is 25. And our IQR is the interquartile range, which is Q3 minus Q1, which in this case is 10. So the last thing we're going to look at here is how we can analyze the shapes of different box and whisker plots. So we have something called skewed left, skewed right, or symmetric. So here you can see that basically this depends on how the data is skewed and grouped. So I'll start with symmetric in the middle. When you have a symmetric box and whisker plots, you essentially have whiskers that are about the same, and the median is in the middle of the plot. So you can really see like this half of the data has the same spread or the same distance apart as the bottom half of the data. And the median is truly in the middle of that whole plot. So it's very, very centered. So if you think about the word symmetric, it basically means it's centered, it's the same on both sides, is how it looks. Now, if you have data that is skewed left or skewed right, essentially what that means if it's skewed left is that the left whisker is longer than the right whisker. So if you look here, you can see that this whisker right here is quite a bit longer. You can also see that most of the data is on the right side of the plot. So here, if you were to, divide this whole plot in half, so here we have our entire plot and here's the middle, well, we have more data here on the right. You can see there's more data here on the right-hand side because we have all of this quarter, so half of the data for sure, and then we have a little bit more. So when we have more data on the right and the left whisker is longer, it is called skewed left. Then from here we have skewed right when the right whisker is longer than the left whisker. So it's just the opposite. And when most of the data is on the left. So when most of the data is on the left, so remember again, we're dividing this whole plot in half. And we can see it's got half the data plus a little bit more. If most of the data is on the left, this is called a skewed right graph because this whisker is longer. So let's take a look at some box and whisker plots and try to analyze the type of spread that we have. So here we have two different data sets. We have your class, which has a bulk of test scores, and then we have your friend's class, which has another bulk of test scores. So here, if we look at the spread of data, what I notice right off the bat is that this data right here, so we go from 60 up to 80, and then 80 up to 100. So the median is in the exact middle of the graph because there's the min, there's the max, and 80 is exactly in the middle. And then everything appears to be about the same. These are 10 apart, these are 10 apart, and then even the whiskers are exactly 10 apart. So whiskers are, 10 long. Each side of the box is 10 long. This whole thing seems very, very centered. So this particular box and whisker plot is what is called symmetric because it is very, very centered on that number line. Now here, if we notice, we have values going from about 68 up to 100 in this top whisker plot. And what I notice is that half of the data occurs between 90 to 100. And I've got 75% of the data between 85 and 100. So just by looking at this, I can see that I have most data on the right-hand side and that I have a really long left whisker. When I have a really long left whisker and most of the data is on the right, that is what is called skewed left. So we can see here that while we collected the same type of data in different classes, the one from your class is skewed left with most of the data occurring on the right and a long left whisker, and your friend's class is very symmetric, where everything appears to be very, very centered. The whiskers are the same length, and the median is smack dab right here in the center at 80.